Okay, thanks, Stan. This is our second Rocket Q&A of 2022. Super excited. We made some changes. We made them less frequent, once every 2 weeks instead of once every week, so we can get high quality speakers like Stan and emphasize the value for students. So we prepared some talking points before the meeting, and hopefully students, that's something that's interesting to everyone who came for the Q&A. We're super excited today to have Stan. Stan is currently CTO and co-founder at a company called Taskade. Stan will share more about Taskade. Essentially, Taskade is a team productivity app that is cross-platform, and Stan has been CTO of Taskade and co-founder of Taskade since 2016. Prior to Taskade, Stan was an iOS developer. He had his own company for a while, I think, doing development, and he was also a lead iOS engineer at MeowChat. He was an iOS trainer at the Pragmatic Lab at Bulk Private Limited, and prior to that, Stan also worked in game development at Next Gen Studio, and made a whole long list of games that Justin shared in Stan's brief in Slack. Stan studied multimedia engineering in Polytechnic, so he did not study computer science. He is a career switcher like many of us here, and Stan has kindly offered to share his time with us to share about his journey, specifically about the tech stack that they use at Taskade, the full JavaScript stack, and the possibilities that are there with the full JavaScript stack. Stan and I met in 2020. Stan actually came for a Rocket Q&A in 2020, back when we were just getting started. Really appreciate Stan's support. And we met through Block 71, which is where Stan is right now at his office. There's a community of engineers there. And Stan has been very supportive of Rocket Academy throughout the last few years, and really appreciate that. And I hope that some of us can consider working with Stan or applying to work with Stan after we graduate from Rocket as well. Cool. Without further ado, I think we will leave Stan for his presentation, and we will follow up for Q&A afterward.
Yeah, thanks, Kaiyan. Yeah, that's a nice introduction. Some of the stuff I did, I kind of also forgotten. Yeah. I'm going to share the screen. Desktop one. Okay, so let me know if you can see my screen.
Yeah, we can see it.
Okay, you can see it?
Yeah.
Okay, so hi everyone. So I'm Stan, co-founder and CTO of Taskade. I've been doing Taskade for about 5 years, and yeah, this is we do collaborative team software, productivity software. So Taskade is a unified workspace built for distributed teams. It's help you managers, tasks, notes, and chat all in one place. We focus a lot of team collaboration, coordination, and communication all in a single place. So you can see that like our goals is really to get the 3 C's to be in one, to do the 3 C's well within our products. That has been what drives us to continuously iterate on Taskade and stuff like that. So what built Taskade? So we actually built Taskade with JavaScript and Typescript mostly. So all backend, front end is all JavaScript and TypeScript. It is a contentious point. Sometimes my guys, they do sort of like questions these things, like these decisions, but I stood firm with it. I still believe very heavily on it as well. I will still do it. Like every time I start a new project on my own, I always start with a JavaScript or TypeScript. It is the most versatile and is, in my opinion, the best language to do anything right now. So other technologies we actually love as well, like Postgres, SQL, the main database. So We like relational database, actually any relational database. So MySQL will work as well, but like PostgreSQL is just, we have a slight preference for it. We mainly use it to store like people's projects and users' informations and stuff like that. And team information. So that's how we use Postgres. Redis is mostly used for caching and hot read-write needs. So Redis provide really great data structures on the scale of on the server scales. So when you need a shared data structures that you need to share between multiple servers, Redis provide a great alternative to Postgres. Yeah, they have things like sorted sets, hash, or lists that can go up to millions of items. And read and write is always very fast. Performance is always great. So Redis is a great choice if you're building anything as a complement, sort of like data stored to Postgres and stuff like that. We also make use of something called OpenSearch. For people who are not familiar with it, it's a fork of Elasticsearch that the Amazon forks. So we use OpenSearch for advanced search requirement at scale, mostly for indexing and doing more advanced search for it. That's much we use for OpenSearch for. The next one we really like is Upload GraphQL. We are big fans of GraphQL. All our API needs are done in GraphQL, and we have not had that much problems for it. It does have its limitations when it comes to error handlings and stuff, but GraphQL, so far it has been solid for us. We recently just migrated to version 3, and yeah, we use the Apollo variants of the GraphQL, which supports a lot of very advanced caching mechanism, which we like as well. The next one that we recently just added was Apache Pulsar. It's our messaging backbones. As your product scales and get larger, and then you start introducing different services and stuff, you might need messaging backbones to help you with your systems. So to help you with the communication between the different systems. So we choose Apache Pulsar. There are alternatives like Kafka and stuff like that. Pulsar is much easier for us to manage and kind of works similar to Kafka, so we choose it. A few other things that you guys might be more familiar with was like Next.js. We use Next.js to build our landing pages. Very powerful tools. I think it's one of the best static site generator out there. We have no problem with that. We are a big fan of their works. The next, which we are the biggest fan, and we bet a lot of our companies in, was React.js. It handled most of our front-end rendering needs and stuff like that. We still find that it's one of the best in the industry when it comes to rendering HTMLs and everything. And there's a big reason why most of the big companies all uses React and not alternative, because it's just a beast, or it's just a great tools. Yeah. So these are some of the technology we use, we love, and yeah. You can ask me more questions later about this as well. I will try to share more if I can. So aside from you can build Taskade with JavaScript, what else could we build? You could build mobile with React Native, which is very, very mature nowadays, much more mature when we start using it. Any web tools, web tool kind of technology, you can build with JavaScript and TypeScript. Web3 like the newer Web3s, like you can use Ether.js to talk to things on chain and stuff like that. Those are possible. There's up and coming things like WASM, interoperate with JavaScript, or interoperate with it very well. And like WebGL for like 3Ds and stuff like that. Those are things that is like very pretty and finally able to run in your browser. So I will claim that there are near zero things JS TypeScript cannot do today. Yeah, it's just this is really great, and I think it's a superpower right now in our industries to know JavaScript. But aside from that, I do want to recommend to everyone to like continue to learn. Definitely feel free to pick up new languages to gain new ideas. Because different languages, they take different trade-off. So sometimes it's very interesting when you learn about new languages, you learn about what kind of trade-off they does when it comes to syntax, when it comes to very specific things like, for example, memory management. Some decide to have a garbage collection, that some decide not to, how they work around those kind of situations. It's definitely very interesting to pick those up and compare and contrast between languages. The next is really explore new ideas, newer ideas like immutability. Immutability is very different, is a very big word, especially in the functional side of programming. Basically, it describes that when an object is created, you usually don't change it. If you make any change, you actually duplicate a copy of it, and then with the new change in it. So it's slightly more mind twisting for people who are more familiar with object-oriented programming, with things that are very, how to say, like with the, like usually school teach you about object-oriented programming like polymorphism and stuff like that. Most of the time you are mutating the objects. So immutability focus a lot on not mutating the objects. So that's something very interesting that I encourage you guys to go explore. Unidirectional flow, data flow is also a very hot subject, but nowadays is more or less the given. But back then, before React become very popular, where the king of front-end development is like Angular or Ember.js, unidirectional flow, when introduced the idea where the data flow in one direction and not in the other way upwards. So that when data flow back from where it came from, we call that two-way bindings, and usually it creates a lot of complexities. And it will be very interesting to compare and contrast like unidirectional flow versus two-way binding. This is something that React advocate very, very early on. Some even newer idea are like change data capture. Basically, it's a pattern where you capture every change to a database and then send it to, and then process them like as a replica pipeline from the database. This idea is quite popular nowadays in like things like Supabase, where their real time is done through such a, like usually using Postgres logical replications. They capture all the change from the database and then they propagate outwards from there. That pattern, you can describe it as change data capture. So like these are three ideas that off my mind that's very interesting for me. So there definitely, there's a lot more ideas to explore and in the space of computing. So I really encourage you guys to go pick it up, learn, read new things and stuff like that. Because it is both very fulfilling and sometimes it's quite fun for me as well. Yeah. So I would suggest like learn, practice, build something, and keep repeating that three steps. I think these are the three steps. Like these are the four things that really make you a stronger software engineer down the road. And a lot of people does that. Like they learn, they practice, then they build something, then they keep doing it. Yeah. So one of the things that can be surprising for people is that like on a personal level, I don't foresee me ever stopping to actually stopping this loop. I see myself keep looping for a very, very long time. So the passion is there. And I think that's you like, it's a very fun thing. And then if you get into and it's very rewarding as well, a lot of time. So try to build that loop so that you start to get the momentum going, and then you'll be fine. And yeah, so great. So one of the things like what really define great software engineers. I come out with 3 points. They are generally very, very curious. They are very self-driven, and they enjoy buildings. Like they usually have all these 3 traits, and then no matter which level they are, they will eventually very great. Yeah, it's usually these 3 traits that actually make them such a great software engineer, and not really their skills. Their skill is just a function. It's just an outcome of these three traits.
Awesome. Thanks for that breakdown, Stan.
Yeah,
Students have been asking questions in the Pigeonhole link, which I've shared in the Zoom chat. So feel free to follow with more questions there, guys, the students. I also have a couple of questions of my own, which I think I'll use to start off our discussion. And first on my list is, you mentioned JavaScript and TypeScript being really important for Taskade. Why JavaScript and why TypeScript?
Okay, so if you don't mind, I share a bit of my history. Yeah. I like when you guys helped me build my profile previously, right? You know that I start off with game development, and I actually have a long history of languages that I pick up over the years. So to name a few is like C, C++, Java, C#, Flash action scripts, what else? iOS, Swift. iOS is not language. Objective-C, Swift, and Python, Ruby, and stuff like that. Like, I really learned a lot of language, and throughout my earlier part of my careers, right, the one bet I bet against was actually JavaScript. So I've been betting against JavaScript for the longest time. And then because most of the time in the early days, people are saying like, oh, JavaScript is just a kid language. So you can see all the language that I kind of learned, they all are like very meaty and, very like, you tell people, some people will be impressed about, but like you think about a lot of these languages no longer are as popular. Objective-C is one, ActionScript is another. You have newer language like Rust trying to replace C++. You have language like Go try to replace C. And so that if you look at JavaScript throughout the years, right, it have stand strong and it start eating other people's pies as well. Like Node.js start eating to the backend. And as we go towards a more interactive web futures, web is just going to eat up a lot more of the backend, of the front of the backend. So slowly you start to see that web is actually eating up a lot of everyone's pie. Everyone now become very specialized in this very specific areas, but all the generalized area, the web are like starting to like eat them up and stuff like that. Like if you study, like for example GraphQL, you realize that a lot of the code on the front end, now a lot of the code is more like a lot of the logics on the front end make it very a lot of the complexity is in the front end. The back end is only writing like resolvers and just resolving all the different part of the information and then to return to a front end. Front end is usually doing most of the meat nowadays. So it kind of aligned with what originally when I started to say, okay, let's not bet against JavaScript anymore. Let's like really learn JavaScript during like the 2016-17 period. And because I like it is a 15-20 year beast that have just continued to grow and have not shrunk. And I saw that, and it have not changed. Like it's still that same beast, and it have even grown even larger into with web assemblies, and with TypeScript.
Speaking of TypeScript and related to that, Chuan-Xin had some really good questions. Chuan-Xin, are you here? Chuan-Xin had some really good questions related to this. He had two questions. One is industry's perspectives around JavaScript and TypeScript. As you mentioned earlier, I think in the past it's seen as a kid language. Chuan-Xin feels that Chuan-Xin, maybe you can, despite its popularity online, it's still rarely seen in industry, seemingly preferred only for rapid prototyping and hackathons. Chuan-Xin, maybe you could elaborate on your question as well.
Okay, my internet connection is a little bit unstable now, so I may get cut off a little bit here and there. But anyway, I mean, just looking at job descriptions of a lot of companies online, like I rarely see full stack JavaScript. Online, you see people advocating for it a lot, but I guess I only really see it for like personal projects and hackathons where people want to have a prototype set up really, really quickly. So the first part of my question is, why is there still not such a huge takeoff in full stack JavaScript yet in the industry? And secondly, for those who are using, other kinds of backend that they have set up a long time ago using Python, PHP, Java, and so on and so forth, how costly will it be to switch from their backends to actually, going on full stack JavaScript? Is there a net cost to it? Are there any, potential benefits to actually, migrating over to full stack JS with their existing backends?
So for it is a great question. It's like there's still a lot of industry expertise in a lot of the other languages like Go, Pythons and stuff, and they have built their own mode. Like in terms of like for Python, it will be machine learning. For Go, it will be micro, like near production level microservices without much effort. So there are a lot of people with a lot of those knowledge. So I would suspect that most of the time it's really a preference of people, like for example in my positions, like what do they think? So they really think that it's easier for them to hire for like this group, their expertise in those areas, then they will decide more of that. They decide to go with more of like maybe Python or Go or even like Rust and stuff like that. It likely most of the time is a decision made on the higher up, depend on the person's skill sets. But I would say that most of them can't run away from JavaScript. That means when it comes to build back front end, there's no alternative for building front end other than JavaScript or TypeScript. So if you are doing anything user facing, like you either have to do JavaScript or I can't think of an alternative for that right now. So that's it. So like, sorry, so what's your second question? Yeah.
I guess the second part is why hasn't it like taken off the way it should in the industry, and
okay,
migration, how costly will it be to migrate over, and would that be a net cost or a net benefit in the end?
Okay, so migration is I tackle question. I try to tackle migrations first. Then after that, I tackle why hasn't it taken off? Migration, it depends on actually really where the code base is in. If the code base is already fully built and then functioning, then any kind of migration is super expensive. But if you just started out, right, then there's very few, like it's really about personal choice. It's about your team, who you surround yourself with, what they are comfortable with, and if you say this direction, will they be able to like follow you effective or not? The second part will be why haven't it take off? Actually, I think that it actually do take off already. So for example, if you look at most of the open source projects, right? Like if you look at like Web3 projects and stuff like that, most of them are written in JavaScript and TypeScript. So otherwise, it will just be written in Solidity. There's very few that is written in any other languages. So if you, unless specifically they use like, for example, Rust to write on chain or stuff like that. So I actually saw more, maybe from an industry point of view of like, if you are applying for big company like Shopee and Grab, where they might have already a very specific set of technology they're already using. So you might not see that much of that. But I would say that if you join any startups or any small companies, like it's almost the language that everyone kind of need. Yeah. So I would argue that it's already took off. Yeah.
Related to that, Changqing, also another question about TypeScript, because TypeScript seems like Taskade is using TypeScript everywhere. And Changqing's question was, TypeScript is a superset of JavaScript. How true is this, and how important is it for us to learn TypeScript now?
TypeScript is a superset of JavaScript. Yeah, that is very, very true. Because you can actually compile, like you can actually run your JavaScript directly on TypeScript, and it will still compile for you, even though if it complains. Like you can configure the TypeScript compiler to like be a lot more less strict, such that it will still take in your JavaScript codes. This is pretty much true. We still have codes that so when it comes to build, how our build system works is that we still have codes from we have TypeScript compiler down to Babel. Then we use either Babel directly compiled to codes, or Babel we use Babel through Webpack to compile the final package to send to our clients. So a lot of our codes actually have a mixture of TypeScript and JavaScript. In the use between them very without much problems. So I would say that TypeScript is a superset of JavaScript. Yeah, that is very true. We never hit any limits. Yeah.
So in that case, right, how urgent is it for JavaScript developers to move on to TypeScript like immediately?
I think it's okay. TypeScript is become more and more TypeScript. So if you learn JavaScript, you're already learning TypeScript to a certain extent. So that part you don't really need to worry too much about. The TypeScript, the reason why we use TypeScript is that we are dealing with like thousands of files of interconnected connections and stuff like that. So we want to make sure that at least we can get some level of confidence when making changes. And then like we want a lot of help from the Visual Studio Code to tell us that, hey, this file, your function name is wrong and stuff like that. But when it comes to smaller projects, JavaScript is more than sufficient. So it's really depend on like your preference. your like where you are as a software engineers, and once you are ready, then you can start picking up, and then you can mix and match your JavaScript and TypeScript. So yeah, it's a I wouldn't worry too much. Yeah, but once you go, I would say once you go TypeScript, it's very hard to go back to JavaScript because the benefit of typings is something that I'm very used to when I was using Objective-C and C++ and C#. And when I start using JavaScript, it was a little bit of struggle without the help of the typing, without the help of the IDE. So now that I actually switch back to so once we start deciding to switch to TypeScript, we decided to switch to TypeScript around 2019. So our code have been like a mixture of TypeScript and JavaScript for a long time. Yeah, we start to see the benefit of TypeScript in a very large code base.
Yeah.
And
so related to that, David had a question which I thought was quite relevant. What is your decision-making process when you decide what technology to use in your code base? Specifically, I think what I'm curious about as well is how you're saying, Taskade is such a performant application, right? It's handling so much data, so many people's files in real time, in across all different devices. How are you using JavaScript and TypeScript to enable such high performance in the application?
Okay, so part of it is probably front-end development, like front-end performance, like simple things like using don't re-render unnecessarily and stuff like that. So we constantly have to like try to run audits on our code base. Well, when it comes to performance, then the other part is actually more on how you use the database. So we generally database, relational database, one of its strong point is ACID properties and relational integrity, meaning that if between two tables, if you do a link and you delete one rows from the other table, it can delete the other one immediately. So some of these are actually like maintaining too much connections generally are very expensive. And then opening up too much, what's that called? Transactions can be expensive as well. So one thing we try to do is that we actually, we do have a subsystem we built on top of on our database where the synchronizing of data is done on the JavaScript side, and then we only write the data directly to the database. So our write, we are very control of the write pressure on our database, and then we try to release that pressure and like the need to synchronize other part of the data through like our message bus and through like some kind of system that is very similar to change data. CDC. I forgot the name of it. Yeah. So it's I guess it's a mixture of like common front end performance, like things that you can find in React websites that they teach you like, okay, don't re-render this, don't, and also like be very careful with how you write to the database. We were a bit more careful in that areas. Yeah.
David, did you have anything to add on to that?
Yeah, I think the question I have is that, with so many different kind of technologies that solve the same problem that exist out there, is there any specific decision-making process that goes on behind the scenes that you take on to decide what say front-end framework to use? Because right now there's plenty of front-end frameworks that exist out there, do you first identify what problem you're trying to solve, or do you just jump into what you know, and then after that, refactor and or move on to a different framework if you find out that a different framework exists that solves your specific problem? Because there's so many tools, right? And we are limited to the amount of time we have to study, to learn these tools. So just want to kind of understand the decision-making process so that we can identify tools that will be likely to be used by a good portion of the industry, so that we cover most of the market rather than I guess that's my question. Yeah.
Okay. Yeah, it's a good question. Like, how do we decide whether, because every decision we make is kind of like a bet, and a bet can go wrong as well. And there are definitely bets that we put out there that did not work out. We did not get returns in terms of investments on it. So it's a very true problem. I would say it's very hard to get 100%, but we try to hit a decent hit rate when it comes to making these kind of decisions. A big part is actually, like, for example, experience as well. For my case, I start off when I was doing mobile developments during those era, right? The most famous most famous framework that everyone is always sharing about was model view controllers, so MVC framework. And for the most part, actually, MVC framework is it does a decent job, but once it gets to a certain level, it becomes very complex. So during those era, you can see the things that came out like Ember.js, Rails, Angular. They all use the same systems back then, like MVC. All of them are a variant of MVC. Even if I'm doing iOS, like it's also MVC as well. I'm not too sure about Android, but I suspect they also follow a certain level of that. So when React actually first came out, right, it introduced the unidirectional data flows and like a different way of rendering. That is actually kind of opposed to MVCs. So it's like, if I'm at that portion, I think back, right, I actually didn't make a move back then as well, because most of the industries are all using MVC. So if I look at GitHub and what everyone is doing, most of them are actually still doing MVC. But you can start to slowly seeing people get attracted by the React rendering models. And then if you kind of dig deeper to it, you realize that, MVC introduced what we call two-way binding. And a lot of the complexity is really maintaining that two-way binding. You go into things like your UI being oversubscribed. Oversubscribed means that it keeps forcing you to re-render. You are oversubscribing to the state changes, so you keep re-rendering unnecessarily. Or undersubscribed, meaning that the state change, you didn't update your UI, so now your UI is stale. So we keep facing this kind of problem when we're doing MVCs, and the complexity of the MVC system caused by like two-way binding is just too much. Actually, once you get to a large size, and React sort of like solve it in another way. And then that's when you dig deep into it, then you realize that, hey, it actually, like, it is ingenious in how it try to like solve this problem for a lot of people by like say, okay, don't do any two-way bindings. Data just flow one direction. Then it should be easy for you to handle. It's such
so in
a,
terms of
yeah.
So in terms of technical decisions, it sounds like it's more like, okay, what is the technical problem we have, and then we go and find the solutions for that technical problem.
Yeah, but at the same time, it took a while to actually understood what actually, like, when we are in the MVC world, we actually, no one like everyone kind of have a sense of what's going on. That's why everyone always come out with a new variation of how to manage MVC projects. But it took like React to change everyone directions, like thought process and thinking. So in that sense, there's this example sort of like show that it's very it's actually very hard to follow the crowd as well, but following like how the crowd is moving, where they are moving, and also like think about why they are moving to that directions might help as well, because at every snapshot you might not React obviously in today's context is like it's one of the best way to write UI, but when it first came out, like during that snapshot, it took time for them to grow. So if I'm thinking like if there is a new framework right now that is better than React, I wouldn't be knowing it right now, but I'll be trying to be sensitive to where people are, like where their attention are going to, and how sticky are they going to stay there, and then evaluate like what is that technology is solving that React is not solving, and then maybe make a decision from that point. But it's definitely not a foolproof, or like we make mistakes as well along, like in terms of like betting the wrong technologies and stuff like that. Yeah.
David, does that answer your question?
Yeah, it does. Thanks so much.
Okay, moving on to a slightly different theme. We have a bunch of questions, especially top voted questions around the product side and the business, or maybe not business side, but product side of Taskade. So Brian has a top voted question. With productivity as a huge trend today and many similar tools being produced, how do you plan, design, and execute a product that is unique and stands out? And then we have related questions from Ray, for example, how did you end up making Taskade? Was it solving a problem that you experienced? Questions from Sri about the live demo. I see there are features similar to Asana that allow teams to plan projects. Going into the details of the features and the problems that Taskade is solving.
Okay. I think from like how do we started? We as the three co-founders, I have two more co-founders, John and Dion. We started off very, very early on, before even this productivity boom that's happening in our industries, and way before COVID. So back then we see the tools and what is being built, and because I'm in Singapore and my co-founders are in US, so we always have trouble communicating or like collaborating, and then tools don't really work in real time back then. And then we were like, that does not make sense. We should be able to collaborate in real time. Like, of course, there are Google Docs, but like we want outlining tools to work in real time. So actually, it was because of that we started off Taskade, and then that's where we are. We build until today. So regarding how do we stand out between our competitors and peers, we are very focused heavily on the enabling it for the teams, and this is one area that we believe that is the future. It is because part of our pitch very early on before the COVID was that the future will be remote, and we see that coming. We just didn't know that it come the next year. Yeah, it was crazy, and then because we knew that in the future it will be some form of hybrid working. We don't believe. That's why a lot of our pitch was always about a unified workspace for distributed teams and stuff like that. We still very heavily focused on enabling a distributed team to collaborate very efficiently. And this is still one of our key missions into building products, building Taskades. Yeah. So that key missions is we will have to how to say, we mostly execute around that key missions, and then we try to build Taskade towards that. We also listen to our customers and what they say, and then we try to evolve the product and iterate the product through these means as well. Sorry, there's one more question, right? Which one then?
I think that addressed the how Taskade plans to stand out and how it got started, what problem we were solving.
Yeah.
Brian and Ray or Sri, do you have any follow-up question?
No,
I
that's
have-
it. Yeah, sorry.
Sorry. Go ahead, Ray.
No, I don't have. I think for me that's clear enough. Yeah.
So,
Sri is your.
Yeah, I was just wondering in terms of like, so sort of your vision for Taskade in terms of moving forward, what other features you're thinking of? Because I guess from a project manager perspective, in terms of, I mean, there's a lot of, tools for planning the projects, but usually I find it's a bit annoying to not have like a performance matrix for the project once it gets going, and then monitoring the project as it matures. It's usually not the same tool. So I was just wondering, has anyone sort of planned to like link the two together?
I think, like one of the areas that Taskade right now don't really do as well is like reportings and like generating like performance and stuff like that. But what we actually build into our products that like kind of differ from some of our competitors is that we actually build a very Git-like system into every changes to the projects. If we continue to expand in that directions, right, we are definitely open to processing, like post-processing a lot of these kind of informations from like, like for example, in your Git, like process all the commits that you have performed on the Git, and then do some analysis for our user and provide them those analysis for their like to help them with their work. We were a little bit more. We are working towards the directions. We are just we probably not there yet, but that is one area that we trying to unlock as soon as possible. Yeah.
Cool.
Quick question from a few folks, Mike and Sri. How big is the team? Are they in Singapore? What are the plans to expand the team?
Oh yeah, so the team here we have about 2, 4, 5. We have about 7 people doing engineering. 5 of them is in Singapore. Actually, no, 6 people doing engineering. 8 people doing engineering. 6 of them is in Singapore. So most of our engineering team is in Singapore. The whole company right now is probably about 10. Yeah, not a large company. So we are definitely trying to get as like we still have a few milestones to reach. But once we hit those milestones, then we'll be on like trying to expand as fast as possible. We definitely heavily focus on expanding in Singapore. Yeah, so most of my team member they are in Singapore. Yeah.
What's the biggest focus right now?
What's our biggest focus? We are introducing from a very technical point of view, we are expanding our data format to the 3rd version, the V3, and the V3 will support a few more like ability to like we support add-ons, but so we are going to move some of the add-ons into the document level, and then by moving it to there, we could potentially like process those information in a more efficient manner, and then extend and provide very more interesting functionality down the roads. Yeah, so we kind of at a step of like improving the details of our product, like the fundamental data structures. Yeah.
Yeah, that's awesome. That's difficult and very high leverage work.
Yeah.
Okay. In the last few minutes we have left, I'm going to switch gears a little bit and move a bit away from Taskade and more into Stan's personal journey.
Okay.
So Stan, as you know, most of us here are career switchers, and I know that given your background in multimedia computing, you're also a career switcher yourself. Can you tell us a bit more about your career switching journey? Like, why did you decide to go into coding, and how did you become a software engineer having not studied computer science?
I see. So when I was, it's been a while since I thought about my past. I always kind of I knew I like games because I always play when I was young, and
Yeah.
that's the excuse to be in front of computer. Like I'm going to be a software engineer or going to programmer in front of my engineer. So or I'm going to be a game developer. Yeah, I remember. Yeah, and game development means that you design the graphics or you do the engineering work, and that's it started off as an excuse to my mom, but eventually it actually became self-fulfilling. And as I grew older, during my multimedia computing, the nice thing is I get to expose to both sides, like do a bit of coding, but I'm also doing a lot of like multimedia stuff, like video editing. And one of the more interesting thing I did was that they have these teachers that used to work in Nickelodeon that teach you how to do Flash animations, animation on Flash. A lot of what I learned there was very tedious. It was too tedious, so it was but I was always very interested in like creating beautiful graphics, like 3D graphics. So you will go to like CG Society and then like just look at all the beautiful graphics and stuff like that. So I was not very sure back then. I think what really made the change was that I happened to have my the FYP teachers that got me my first jobs, which is programming jobs. Yeah. And then I wasn't like actively looking. So he was like, okay, I just went NS and this guy have a studio. Do you want to check out whether you want to join them or not? Because our FYP was doing a game. So I went to chat with him, and then that's where I start off learning on the jobs. Like a lot of the things at that time, I'm not ready to actually work on a lot of things, but my boss gave me a lot of opportunities to learn. So
we have a couple students here who are actually keen on game development as well. So Gary had a question. Maybe Gary, are you there? Maybe you want to elaborate?
Yeah, hi. Just wondering, maybe you can share a bit more on your perspective on the game development industry. And also like for someone with no relevant experience, like is there any like advice you could give, like, or what language or framework, or are there any like soft skills that need to be picked up to actually enter the industry?
I see. It probably, if through soft skills you want to meet up with more people in the industries, and then sort of like share with them, like really sort of like through a way you can share that, like that's your soft skill. Because in the industries you are talking about, like game actually have one of the hardest game industry is probably one of the, like playing the game at like playing the like like when we play games, there's like easy, medium, hard. Like I always think playing game industry is like playing the game in the extreme mode, like super hard, because you're talking about getting the sound designer, like getting the story right, getting the gameplay mechanics like fun, Then you have the engineer who have to be graphic engineers, physics engineers, or gameplay engineers. And then as the game get more and more complex, like the number of the role of like project managers or producers becomes so much more important because they need to synchronize and like work around with so many other people. But like that's as far as I know, but like so like if you are starting on your own, right, I would suggest definitely reduce the complexity of your games, keeping it like as fun as possible, and like keeping the game mechanics simple, easy to execute. That those will be like those will give you enough because ultimately there's still money needed to pay for all the people who's building the games. So if you can like reduce the resources needed to build your game, then your chance of succeeding will be much higher. Yeah, but in today there's like a lot of tools like Unity is a very good tools. And I think Unity just dominate the whole game industry. It's definitely one of the like tools you probably want to pick it up on. Yeah.
So
Awesome.
you're saying based on that Unity is currently sort of like the preferred.
Yeah, so far that's what I limited knowledge. It seems like Unity is the one that everyone nowadays uses. Yeah.
Thank you so much, Stan, for being with us today.